numbers. Rational numbers. Rational numbers. What are rational numbers? These are numbers that can be expressed as the ratio of two integers. If I say ratio of two integers, that is number that can be expressed as fraction. Let's say P over Q, in form of fraction like this, where Q must not be equal to 0. This symbol here means must not be, that is not equal. Is the numerator, and Q is the denominator. As you can see, numbers that can be expressed in form of this, P over Q in form of fraction, where P is an integer and Q is an integer. And this Q, no 0 is an integer too. So except 0, Q must not be 0. Then once it can be expressed in form of this, you should know they are rational numbers. Example of rational numbers. Examples are 1 over 2. You can say 5. All whole numbers, all counting numbers are rational. Why? They can all be expressed as a fraction. Just like 5, you can say 5 over 1. So you can say 6 over 1. They are all rational numbers. So 1 over 2, 5 over 1, 6. You can also see them in form of roots. You can see them in form of roots. Like if you have square root of 4. Now this square root of 4, square root of 4 is written as 2. So you should know that square root of 4 is also a rational number. Why? It results in a whole number. And a whole number can always be expressed as a fraction. So and so on like that, 3 over 4. All these fractions can also be expressed in form of decimal. And decimal, there are some decimal that have endpoint and decimal that does not have endpoint. For example, now like this 1 over 2, you should know 1 over 2 in decimal, if you should divide it, is 0.5. 1 over 3. If you should divide 1 over 3, you realize that the result should be 0.33333 and so on. I believe you can still collect that to divide now. Your divisor outside is inside. Can 2 goes in 1? No, 0. Put decimal point. Then you add 0 to 1. So 2 in 10 is 5. 5 times 2, 10. Subtract 0, 0. So those are basic learnings. So I start applying that here. 3 outside 1. So can 3 goes in 1? No, 0.20. Can 3 goes in 10? Yes. 3 times. If you count 10 and remove 3, it will remain 1. So you can only go 3 times. So that will be 3. Use that to multiply 3, that will be 9. Subtract, be left with 1 again. Since 3 cannot divide 1 exactly, you have 0, don't forget. So 3 in 10, still 3 times this 9. So you notice that it keep on giving you 1, and you keep on having repeated digits here. There's a way you should identify it to be a rational number. So if the decimal form of a number stop just like this, as I've said, terminating decimal, if it terminates like this, either it terminates or the digit after the decimal points are repeated, you should know they belong to rational numbers. But in case when you come across a decimal form that does not stop and at the same time the digit after decimal point does not repeat, you should know that one can never be expressed in form of fraction. Take for example, let's say square root of 2. You realize that it results in something like 1.14142 and so on like that. Just like we have pi. The value for pi 3.141259 and so on like that. You realize that all these ones, the digit after decimal point does not repeat. At the same time, the digit does not stop. Doesn't have endpoint. So you should know this one can never be rational numbers. Take note that if a decimal form of a number stops and repeats, that is terminating decimals, then it is said to be a rational number. So let's move to the next number, irrational number, which I've already explained. These are numbers that cannot be expressed as the ratio of two integers. In other words, you can say if a decimal form of a number, does not stop and repeat, that is non-terminating decimal, then it is said to be an irrational numbers. So what are the examples of rational numbers now? Just like I've explained it, all those numbers that the decimal form does not stop and does not repeat, they are said to be irrational. And you notice that all these numbers cannot be expressed as the ratio of two integers, in form of fraction. So what are the examples now? Just like us, there we have square root of 2, we have pi, we have other square root of 3, exponential, and so on like that. So all these ones, you should know they are irrational numbers. Why? They cannot be expressed as ratio of two integers. That is, in case of square root of 2, 1.14142 and so on like that. In case of pi, you can see 3.141259 and so on like that. It's not necessary that you always see irrational numbers to be positive. In some cases, it may be negative. It's still a whole number. So -8/1 is still a rational number. Why? It's an integer. The only condition that cannot make it to be a rational number is when the denominator is equal to 0. When the denominator is equal to 0, it will be undivided, so it cannot be a rational number. That's only the condition there. Number 8, real numbers. So as I've said, numbers we have discussed are the ones that you normally come across. If you consider integers, now I said integers comprises both the negative and positive whole numbers. And these integers, what are the positive whole numbers there? We have 1, 2, 3, 4, 5, 6. They are simply the counting numbers. So you can easily see that natural numbers can be found under integers. So I can still say natural numbers belong to integers. If you notice that rational number comprises of all other numbers like natural, integers, odd, even, you can see that now, prime. But there is no way we can see a number that is rational that is also irrational. It's not possible. So I can simply conclude that real numbers are numbers that comprises both the rational and irrational. That is all the numbers that we have been discussing. These are numbers that comprise both the rational and irrational numbers. When I was explaining integers, I explained something like number line. I said that other numbers on that number line that we only consider the whole number there. So that number line, normally the full name should be V number line, because V number line is a line that comprises rational and irrational numbers. And what are the examples of rational numbers? I told you all those whole numbers and numbers that can be expressed as ratio of two integers. So I can say -8, I can say 5, I can say 1/2, I can say 3/4, and I can include my irrational numbers like square root of 2, square root of 3, pi, exponential, and so on. And all these numbers, as I've said, can be represented on a number line. Number line is no new to us again. We normally have the reference point 0, positive numbers to the front and negative number backward. Now you realize that I told you then that between all these numbers, you can still see smaller numbers, like between 0 and 1, you can still see something like half. Between 1 and 2, you can still see something like 1.2, 1.3. Did you get that now? So I only listed out the whole numbers there, and the whole numbers there are the integers as I've explained. However, there are more to the numbers on the number line. I can see my pi is in between 3 and 4. Yes, you can see pi here because the value of pi is 3.141 and so like that, which is between 3 and 4. So this is what we call V number line. There is a particular symbol that we normally use to denote it. That symbol, let's manage this side. That symbol is in form of letter R. Yes, in form of letter R like this. Now put something like I at the back. But once it's something like letter R, you should know that referring to V numbers. So the last one there is complex numbers. Yes, complex numbers. This is one of the advanced topics that we are still going to consider later on. There is a general symbol that we normally use to represent complex number, just like we have the symbol for real numbers. So that symbol is in form of letter C. Then you put a line like this there, form of letter C, then a line to cut it like that. So whenever you come across a symbol like this, you should know that you're referring to complex number. What are these complex numbers? It's not something that is difficult to get. Now, this complex number now is, I can say, is the father of all. These are numbers that consist of two parts. I will just say two parts. They are, I will say the first one, real numbers part, and the imaginary numbers part. Now, what are these V number parts? V numbers are no new to us. This is what I've explained earlier. The only thing that is new to us there is imaginary numbers. For instance, if we are to find S, when we have something like x squared plus 4 is equal to 0. Some can say the answer is -2. But let's check. Maybe the answer is 2 or -2. Now to solve this, what we need to do here is we have to find the unknown. And the only way we can find the unknown here is by taking the +4 here to the other side. And how do we do that? Normally add the additive inverse to it. So let's find the additive inverse of 4, and the additive inverse of 4 is -4. So you add -4 to both sides. So +4 minus 4 becomes 0. So we left with only s squared there. And 0 minus 4 is always -4. And the question here is, if we are looking for s and it's having square, how do you normally eliminate the square? You normally take the square root of both sides. Let's take the square root of both sides. So square, we cancel square roots. Now left with x equals square root of 4. Now this is where the problem lies. To some, they can just say the answer here is -2 because they are saying 4. No, your answer can never be -2. Why? You are having imaginary roots here. This is an imaginary root. You are having negative number under the root. This one is different from when you are having square root of 4 or you are having minus square root of 4. Is different. This minus now is without 4. You can see. So you can't just say the answer is -2. To confirm or to make it easier for you, just take your calculator, press square root of -4. You realize that you give you mathematics 0. So this is an imaginary root. Whenever you see a negative number under root, it's not like this. They are called imaginary roots. Now, how can we now solve this question that is having imaginary roots? And that is where we have imaginary numbers. To solve this, the imaginary number is given to be square root of -1. So whenever you see square root of -1, you should know it's an imaginary number, but it is always denoted by a letter. So which is denoted by letter I. So it's always denoted by letter I. Some cases you can use J for it when you get to some levels. So they are still the same thing. Once it is referred to as imaginary root, you should know that referring to square root of -1. So whenever you see square root of -1, you should use it as I. So square root of -1 is written as I, and call it imaginary number. Or in some cases you can say imaginary root. So how do we now solve this question? Have the knowledge of imaginary number. S is equal to square root of -4. Then we can separate square root of -4 to be square root of -1 times square root of 4. To people that really understood how to solve this, because you multiply numbers under the roots. If you have to multiply this one is going to give you square root of -1 times 4, which will still give you back -4. You can see that. So, but don't forget that this is imaginary number and is noted by what? I. So as simply say our final answer is I square root of 4. Or you say square root of 4i. You can see that there is solution for this, but that one is under complex number. So this is an imaginary part of a complex number. Why is it an imaginary part? Because it has the imaginary root I in it. So what are the examples of complex numbers that we have? Examples of complex numbers. I can have it like, let's say 3 plus 2i. You can see that now. It must comprise both the real number parts and the imaginary number parts. You can see. So you can see it in any form, 5 minus 4i. So whenever you see a number that is having imaginary parts as well as real parts, you should know that number is a complex number. So that's how to identify complex number. It always comprises both the real number parts and the imaginary number parts. And that's all concerning kinds of numbers. There are some basic questions that do come out in O levels or in UTMEs. exams. You can just say solve problems since we'll be solving the problems here. So most of the questions though that are always under OBJ questions, you can come across question like which of the following is not a rational number? Which of the following is not a rational number? So you can say option, you can put 2, 1/3, square root of 100. You can say the square root of 10. Now what's the question? Which of the following is not a rational number? That is, they're asking for a rational number here. It's easy to identify since you know what rational numbers are. All let's say rational numbers are numbers that can be expressed in form of the ratio of two integers, that is in form of fractions. And I told you that there's an easier way you can identify rational numbers, that whenever you change it to decimal, that once the digit after the decimal point stop, or you have repeated digit after the decimal point, you should know it's rational. But if the decimal does not terminate, that is, if it does not stop and there are no repeated digits there, you should know it is irrational. So from this option, you should know your answer without wasting your time. If you know 2 is rational, is a whole number which can be expressed from a fraction 2/1. 1/3 is rational because it has repeated digit after decimal points, which I have explained earlier. Square root of 100 is 10. You can see square root of 10 is going to give something like 3.162 and something like that. So you should know that this one does not stop, and the digit after the decimal point does not repeat. So you should know that this is resulting to non-terminating, and that is irrational. So the correct answer here should be option D, which is square root of 10. I believe you can see that now as easy as ABC. Find the average of the first 4 prime numbers. First 4 prime numbers, let's say greater than 10. Solution. We have to find the average of the first 4 prime numbers greater than 10. First 4 prime numbers greater than 10. That should be what should be in your mind. So first 4 prime numbers greater than 10. What are the first 4 prime numbers greater than 10? Now what are prime numbers? I've explained earlier now. Numbers that only possess 2 factors, 1 and itself, don't forget. And there is a way you normally get that. So starting from 11, check 11. It's only 1 and 11 that can divide 11. If you check 12, you can see that even seeing 2 is an even number. It can never be prime. You can only see odd numbers that are also prime. You can never see even numbers that are also prime. So you have to neglect anything concerning 0, 2, 4, 6, 8 at the back. So the next one we are going to consider is 13. If you check 13, you should know that it only has 2 factors, 1 and 13 itself. If you consider 15, it possesses more than 2 factors. And what are these factors of 15? You should know that 1 will divide 15, 3 will divide 15, 5 will divide 15, and 15 itself. That should be like 4 factors that can divide 15. So you should know 15 is not a prime number. So the next prime number should be 17. 17. You can see it's only 1 and 17 can divide 17. And the last one is 19. There's only 1 and 19 that can divide 19. So those are the first 4 prime numbers greater than 10. And we have to find the average. That is, you sum up the numbers Then you use the total number that you can see there to divide it. To find the average of these numbers, now all what to do is you add. If you say sum addition now, you add up the numbers like 11 plus 13 plus 17 plus 19. Then divide by the number, total number you can see there 1, 2, 3, 4. We only have 4 numbers. You can see that. That's how to find out. If it is 3, it will be divided by 3. If it is 2, it will be divided by 2. So that's how to find average of numbers. If you should add 11, 13, 17 together, you realize that it will give you 60. So we are having 60 divided by 4. And how many times can 4 goes in 60? 4 in 6 is 1, made that 2. Put the 2 here, making 20. 4 in 20 is 5. So you should know it's 15. Which of the following is the greatest? Which of the following is the greatest? You can just say option A minus 10, option B minus 100, option B minus 1, option D minus 1000. The least number you can see here should be minus 1000. So after minus 1000, the next number should be minus 100. The next one should be minus 10. Minus 1 is still greater than the remaining ones. You can see that. So the correct answer here should be what now? B, option B, which is minus 1. So minus 1 is the greatest of all the numbers. This comes to the end of the class. Science of Numbers, Volume 1, Part TV, which is the last part. Thanks for watching and learning with me. Please don't forget to like, share, and comment. And please don't forget to subscribe.